Okay, so now I'm going to go over a different type of equations. These are known as radical equations, and these are equations that contain a radical expression, or basically roots with variables, such as like the square root. It can be a cubic root, but it's basically roots with variables in them. Now, to solve radical equations, we have 3 steps that we need to follow. First one is to isolate the radical, or the root. Then raise the power depending on the root. So for instance, if we have a square root, then the power that we're raising to is 2. If we have a cubic root, then we're going to do a power of 3. If we have a root of, let's say 10, then you're going to do a power of 10. Okay. So for the first example, I have the square root of x equals 10. Well, as you can see, the radical is already isolated. So step number 1, we don't really have to follow it because the radical has been isolated. Okay. So we have square root of x equals 10. The next step, so step number 2 is raised to the power depending on the root. So this root is a square. Whenever we want to have a number, we say that it's a square. So it has a root of 2. So then we're going to do a power of 2 on both sides of the equation. So this and this go away, and we end up with x equals 10 to the second power. So x equals 100. And then that is the solution for this particular problem. Another example, this is really similar to example 1, and this one is the square root of b minus 4 equals 30. So if you notice on this one, step 1 has already been done for us, so radical is isolated. So we're going to jump to the second step, which is raising to the power depending on the root. So here, because the root is a 2, then we're going to raise it to the second power. If we do it on one side, we do it on the other side. So then the square and the square to cancel out, and we're left with b minus 4 equals 3 to the second power, which is 9. So that's step number 2. And step number 3 is to solve for the variable. So we want the b to be by itself, so that negative 4 has to move to the other side. Because it's negative, it has to move as a positive. So b equals 9 plus 4, which is 13. And now for the exercise 3 for radical equations, we have 10 plus the square root of 10m minus 1 equals 13. Now this one, in contrast with the other two, now we don't have the radical expression completely by itself or isolated in one side of the equation, right? We have that 10 plus and then the square root of 10m minus 1. So basically, this right here is what we want to isolate. So we want to get rid of the 10. How do we get rid of it? By doing the opposite of what it's doing, which is adding, and then it's a positive. So minus 10, and then minus 10. So 10 and 10 are going to cancel out. And then we have the square root of 10m minus 1 equals 13 minus 10, which is 3. So step 1 is done. Now we'll do step 2, which is raising to the power, right? So this is a square root, so we're going to do square on both. So the square and the square are going to cancel out, and we're going to end up with 10m minus 1 equals 9. We add a 1, and 10m equals 9 plus 1, which is 10, divided by 10, m equals 1. And we are done. Now let's go ahead and go over another example. So the fourth example for radical equations. So this one is the square root of 3n equals the square root of 4n minus 1. So now on this one, it's a little bit different because now we have radicals on both sides of the equation. So we're not isolating. We're going to go ahead and skip step 1 and then go to step 2, which is raising to the power. Here again, these are square roots, so we're going to go ahead and raise to the power of 2. So the square and the square root are going to cancel out, and we end up with 3n equals 4n minus 1. Now, I want the n's by themselves, so I'm going to go ahead and move the 3n to where the 4n is. So minus 3n, remember we always move the term that has the smallest number with the variable. So we end up with 0 equals 4n minus 3n is 1n minus 1. I'm going to go ahead and add 1 on both sides. So 1 equals n. And we have solved for the variable. And let's go ahead and go over one last example. So if you notice again, it's the same steps, except if you have a squared on both sides of the equation. So for example 5, we have b minus 6 equals the square root of 18 minus 3b, and then we have minus 6. So step number 1 is to isolate the radical. So we want to leave this piece by itself on that side of the equation, right? So if we need to get rid of that negative 6, so we get rid of it by adding, because it's a negative, so we do the opposite. This cancels, and then here I'm noticing that negative 6 plus 6 is also going to cancel out. And then we have the square root of 18 minus 3b. Now from here, because this is square root, we're going to go ahead and raise to the second power. So then the square and the square root are going to cancel out. However, on the left, we end up with b to the second power, which is going to be b squared equals 18 minus 3b. So now what I'm going to do is I'm going to get all terms on the same side. So I'm going to go ahead and subtract 18 and add 3b. So this cancels on the right, and we end up with b squared plus 3b minus 18 equals 0. And then I want you to notice how we have b squared and then b in the middle and then just a number at the end, right? That is the standard form of writing equations that have a power of 2. So what we're going to do now is I want to go ahead and find two numbers that when we multiply them, they give us negative 18. So this is the last number, right? Let me go ahead and make that multiply. Oops. Which is the last value, and then on the bottom I'm going to have positive 3, which is the one in the middle. And I want to two numbers that multiply to negative 18 and add to positive 3. So those two values will be 3 and 6. And because 3 is positive, then this 3 is going to be negative, and the bigger one will be positive. So then this becomes b minus 3 times b plus 6 equals 0. And then by the zero product property, we know that if we're multiplying and the answer is 0, then at least one of the equation has to be 0. So we have b minus 3 equals 0, or b plus 6 equals 0. So if we solve, we move the negative 3 to the other side as a positive, b equals positive 3, and b equals negative 6. Okay. And that would be our solution.